why loop efficiency matters.
Efficient loops are at the heart of fast and scalable programs. Small changes in the way loops are written can have a big impact on performance, especially in tasks that repeat many times. Optimizing iterations helps reduce processing time, save memory, and keeps your code responsive, whether you're working with large datasets or real-time applications.
Minimize work inside loops.
Always do as little work as possible inside a loop. Move calculations or function calls that don't change with each iteration outside the loop. By avoiding repeated operations within the loop body, you cut down on unnecessary processing and speed up overall execution.
Choose the right loop structure.
Different loop types have different strengths. For simple counting, a for loop is usually clearest and most efficient. When reading from collections or streams, consider using built-in functions or iterators, which are often optimized. Match your loop style to the task for easier to read and faster code.
Avoid modifying collections while looping.
Be careful when changing the size of a list or collection you're looping over. Adding or removing items while iterating can cause skipped items, errors, or slowdowns. If you need to modify a collection, consider making a copy or marking items to process after the loop finishes.
Break early when possible.
If you find what you're looking for, don't keep looping. Use break statements to exit early when the task is complete. This saves time by preventing unnecessary iterations and is especially useful when searching for a specific element or when a condition has been met.
Summary: small changes, big impact.
The efficient loops make programs faster and use fewer resources. By minimizing work inside loops, picking the right structure, avoiding unsafe modifications, and breaking early, you can optimize your code with just a few simple changes. These best practices are the key to cleaner, more effective software.